In this lesson we're going to examine what happens when a fuel burns in oxygen. That's to say, we're going to look at the combustion of fuels, and by fuel I mean a hydrocarbon. That's a substance which is made from hydrogen or carbon atoms, and when it burns in oxygen it releases lots of energy. Now there is one type of fuel which we'll look at in the next lesson, which is hydrogen on its own. That acts as a fuel. That's not a hydrocarbon, and but in this lesson we're just looking at burning hydrocarbons and analysing the substances that are produced when this reaction takes place. So to do this we're going to use this apparatus. I'm going to use a Pyrex funnel here to withstand the heat. We've got a delivery tube that's going to pass through an ice bath, which acts as a condensing unit or a condenser. And then finally at the end we're going to use a downward delivery method to pass a gas through a substance called lime water. So you'll guess that that gas will be carbon dioxide. Okay, I'm going to pass carbon dioxide through this lime water and observe the changes that take place. So this is our analysis equipment, and what we're going to do is we're going to analyse methane or natural gas. So we've got methane coming into the Bunsen burner, and at the moment you'll see that the Bunsen burner flame is yellow. We don't want that. What we want is a blue flame. This is produced when the methane is completely burnt by oxygen. And to do that we've got to make sure that we've got an adequate oxygen supply. And to do that we need to open the hole on the Bunsen burner. Okay, and that ensures that we get a nice good supply of air and oxygen. And that ensures that we get the complete combustion of methane. Now when that happens, that more energy is released, you'll notice that the flame changes colour. So you get this blue flame produced as the methane is completely burnt in oxygen. So we can then position the Bunsen burner under the collecting funnel, and the products of this reaction now, and that's methane burning in oxygen, will pass through this delivery tube. And you'll notice that after a while, one of the products, which is water vapour, starts to condense in this condensing unit. Okay, so you'll find that water collects here. And likewise you'll notice that the lime water changes from clear to cloudy white. Let's do that. There you go, it's going cloudy white. Okay, and that is a sign that carbon dioxide is being released. So we can say in this particular case, when we take methane, we burn it in oxygen. That's the combustion of methane. Two products are produced which are demonstrated by this apparatus, one of which is water vapour or water, and the other is carbon dioxide. Now this is for the complete combustion, what we call the complete combustion. Now in another lesson we'll look at the incomplete combustion of hydrocarbons, and that's when there's an inadequate supply of oxygen. But this is the complete combustion. We get methane plus oxygen gives you water plus carbon dioxide. But what is important here is this applies to all hydrocarbons. So it doesn't matter whether you're using petrol, whether you're using propane, butane, whether you're using candle wax. Whenever any of these hydrocarbons burn in oxygen, you always get these two products, always water and always carbon dioxide. So I can shove a candle underneath this apparatus and I will still get water and carbon dioxide produced, or for example I could burn petrol, you still get the same result, okay, providing you've got getting complete combustion. So we can make a general statement about the combustion of fuels. I'll come back to this one in a minute to write out the symbol equations. So we can say that any hydrocarbon, when it reacts with oxygen, when it burns with oxygen, always results in water plus carbon dioxide. Okay, so we'll just move this down a little bit and we'll write out the symbol equation. So we should learn how to do these. So in this case the formula for methane is CH4 plus oxygen, remember that's O2, gives us water, H2O plus carbon dioxide, CO2, up arrow. It's a gas, and you can see that's not balanced. So to do this, let's first of all look at the hydrogens. We can see we've got 4 hydrogens here and 2 on this side. So what we're going to do is we're going to put a 2 here. That gives us 4 hydrogens. But now we can see we've got 2 oxygens, that's 4 oxygens on this side and only 2 on this side. So that's easy, we just put a 2 here. Carbons are okay, everything's okay, the equation's balanced.